Good morning and good afternoon, everyone. This is Werner Ness, member of the Business Committee of Java Card Forum. And it is my pleasure to welcome you to this sixth webinar from the Java Card Forum 2021 webinar series. I hope you enjoyed the previous presentations. And if you could not attend, please feel free to watch the replay of the previous webinar presentations on the Java Card Forum website. Today's topic is a presentation from Karl, Eglof, Hartel, GSMA and Devrient Mobile Security on virtualizing secure elements. Secure elements are used in a wide range of application and business areas, and they are very successful at SIMs in mobile phones. Today, the steps from a SIM to eSIM and iSIM leads to additional requirements of the markets for virtualization. Karl Eglof will introduce the requirements of the markets for virtualization of secure elements. He will also present the current status of discussions and the boundaries relating to Java Card and GlobalPlatform. Karl Eglof received a diploma in physics from Ludwig Maximilian University Munich and spent 13 years at Siemens DASA EADS working on military command and communication systems. He joined GSMA and Devrient Mobile Security in 2000 and since 2001 has focused on standardization. He started his activities with ETSI SCP, but extended his scope also on GlobalPlatform. In 2009, Karl Eglof became chairman of the GlobalPlatform SE committee, and since 2011, he has worked on standardizing different eSIM solutions at GSMA. Karl Eglof today is responsible as Director of Standardization in G&D Mobile Security Division, Trusted Connected Devices. We will answer your questions at the end of the presentation. You can enter them either in the chat box during the presentation or wait until the presentation is finished when we will unmute the microphones. Please also note that you will receive links to the webinar presentation recording and material by email shortly after the presentation. And now, without any further delay, Karl Eglof, please, the desk is yours.
Okay, thank you, Werner, for the introduction. I missed part of it because, very sorry, I'm working from home office. And my DSL line obviously is not the best, and it dropped, and I had to switch now to a mobile hotspot. I hope that the mobile line will be stable. Sorry if it drops out. I hope that I will recognize it, and then I may have to repeat, but currently it seems to be working. All right. My presentation is about virtualizing secure elements. Now, basically, I gave the title to Java Card Forum, and then when preparing the slides, I found out that, yeah, maybe the title could even be misunderstood. And so it could be read like, oh yeah, we are virtualizing the secure elements. So instead of hardware, we go to the cloud, and everything sort of disappears into software run somewhere. So really, to make it clear, that's not the idea. We are not talking about bad things like soft SIM and so on. It's really there's the virtualization technology, and it's now that we know, for example, from the server world, that's now hitting the secure elements. So just to give the context. All right, here we go. I'll talk just a little bit about what's happening in the server world on virtualization. Then I get to some use cases, the real life use cases that we are confronted with. We're doing some standardization in GSMA, in ETSI, in ISO, and I'll bring some details about that, and then I'll go to have a few slides on the impact for Java Card Forum, and also for Global Platform. All right, next slide. So I don't know whether you have run into that, but this was more or less where I was a little bit confronted with virtual servers first. If you go to any of those server hosters and so on, they have racks full of servers, and you can rent some of those servers. And you can rent a real physical machine, which is expensive. And you can simply rent a virtual server. Yeah, and you can see here performance up, costs down. Whether performance up and so on, that might be the question. But at least you can get a very powerful machine. But you're not the only one that's using it. And in fact, there will be many users of it, and each one gets its virtual server, and it really looks like, okay, it's my own machine. There may be a little bit delay upon startup and so on, but even you get guarantees about RAM, about the memory, about the bandwidth, and so on. And yeah, because the hardware, one of those real physical racks is expensive, and it's expensive to rent. That's why I simply split it down, share the cost, because in the typical applications that you run on such servers, you don't really need the full machine. And that's, by the way, then for virtual servers, okay, if you need it, the cost is down, you still have nice performance and so on, and maybe the hoster then, by renting one hardware out to many instances, he can even make more money than renting out the real machine. All right, now just 2 slides on a little bit the technology that's there. And the first one, that's, how to say, the real clean approach. You have a hypervisor, sometimes called the virtual machine monitor, which sort of sits directly on the hardware. That hypervisor doesn't do too much except managing operating systems. And then on top there, you can have different operating systems. It doesn't have to be the same kind. You can have a Linux, you can have a Windows, whatever you need. They all run on the same hardware. And that hypervisor basically makes sure that all those are nicely separated, firewalled, fenced off from each other. They run in their own space. And for the operating system, well, the hardware is virtualized, but it looks like the operating system has their own hardware. That type that you see here, sometimes it's called the native hypervisor or bare metal hypervisor, because it really runs well. It's silicon, but they call it bare metal where it's running. And there are also some others where sort of below that hypervisor, you still have an operating system. So in some way, it's an operating system on top of an operating system. Basically, for the operating system on top, it really doesn't matter. Now there's a second kind, which may be interesting at least to take a look at. Docker, even available as open source. And there basically you have one host operating system, and that host operating system is the same for all. But basically in the application space where you then run your software, the applications that you have are put into some containers. And those containers, again, are nicely fenced off from each other. And those containers then basically can make use of the operating system. And for the applications, it really looks like, okay, they have the operating system for themselves. No other applications and so on messing around. They have the full registry and so on. Don't have any visibility of all the others. And that's really then more on the OS level where you have that virtualization. Now, for what we will talk about in that session, it's really irrelevant how you do it, because we only typically for the standards that we do, we only look at the interface to the outside world. And on the interface to the outside world, when you now connect to any server, that's virtualized and so on, it really looks like a normal physical server. You will not see any difference. And that's why the way on how it will finally be virtualized, even on a secure element and so on, doesn't matter. And that's why even in standards, you will also not find any idea on that. Now, for what we will have to deal about, it's a little bit more here on the containerization side. But again, it from the viewpoint of a standard, that's irrelevant. All right. Next slide. Let's look at use cases. And for the use cases, we have to start in GSMA eSIM. Now, for those that don't know it, GSMA eSIM, in the old days, SIM cards came in plastic. And if you had your phone, you could have several SIM cards. If you want to change your operator, then, well, open the phone, take out the battery, typically it's below the battery, take out the SIM card, plug in the next SIM card, switch on again. Now, there was some trend, well, first it came in the automotive because the automotive folks, they don't like the SIM cards because of the contacts. Because, well, every now and then with your car, you're in an unfriendly environment, corrosion kicks in within the 15 years of a lifetime, or take 20 or 30, whatever you want, and then it becomes unreliable. So they prefer soldering. Now, if you solder it, and if you take a SIM card as it is today, you solder it, then you're basically nailed to one operator. If you want to change operator, bad luck. Now, to avoid that bad luck, in GSMA, we defined something which is the eSIM, where basically the content of the SIM card can be loaded. And that's what we call a profile. So you basically load the operator-specific content in a profile. And then you have one SIM card, you can load several of those profiles, and then you can switch between them. Now, in some way, that's already a little bit of a step in the direction of that virtualization, but really here, the difference is you only have one active at any point in time. So it's really a little bit more like, how should I say, call it a multi-boot system. Whichever profile, well, you can choose whichever profile you want, and this is the one that you boot up, and the other ones are dormant. So not really virtualization, but that's what's out for several years now. We have different standards for M2M, for consumer, and so on. But then we ran into another very interesting problem. And this is today, if you have your phone, many phones have two SIMs. Okay, if it's physical, then you can basically, and if you have 5 SIMs in your pocket, then you can plug in any two of your choice that you want. Now, with the technology that we have for eSIM, well, you have a baseband. Well, a dual SIM phone has 2 basebands. Let me see. I even have, no. Here's my laser pointer. You have 2 basebands. And now what you could do is to simply solder two chips, 2 eSIM chips, and connect each one to a baseband. That's a straightforward approach. Now the problem is, if you have your user and the user now has to download profiles, the user has to choose, okay, do I do it to the left side or to the right side, EACC 1 or EACC 2? And once you downloaded it, if you have 3 profiles on the left and 2 on the right, then your choice is limited because you can pick 1 out of 3 and 1 out of 2, but you cannot pick, for example, take a profile from MNO 1 and 2 or 1 and 3 and get those enabled on the 2 basebands. So not so nice, the user experience that you would have if you sold the 2 chips. All right, then I cannot click anymore. I have to click here. Okay, fine. What's the solution? We call it multiple enabled profiles, something that we are currently standardizing in GSMA. And it's basically simply put all profiles on one chip and allow two of those profiles to be active in parallel. And here you now can see it already. Well, you have the two basebands, and now those basebands need to connect to their profiles. And from what they see about the profiles, it's really like, okay, it's all the data, and it's the typical SIM operating system with all the different commands. And what baseband 1 sees is totally separated from what baseband 2 sees. So it's really, it looks like, okay, there are two operating systems with the two profiles. Now, whether that's the real implementation or whether you have two threads running through the code and each of those threads handling the different set of applications, that's really implementation specific, out of scope for what we have in the standard. Now, what we need in the standard is something here on the interface, because still the chip only has one interface, and we need some multiplexing here. So what we then have between the basebands is what we call logical interfaces, and we have to multiplex the logical interface on one physical interface. And when that's out and running, everything's fine. Dual SIM phones work nicely, and the end user can pick 2 out of the 5 profiles that are loaded. Now, there's yet another use case. And for that other use case, let's go to that slide. So eSIM, as we know today, some MNOs, they have what, let's call it, third-party applications. Inside their profile, today on the SIM cards, take an example, let's say for payment. So there's a MasterCard applet or Visa applet inside that profile. Now, when the profile is enabled, everything's fine. The end user can make his payment transactions. Now, the problem is that if you now have several profiles and the user decides, yeah, well, maybe, well, let's assume it's even the credit card, the business credit card, and then in the evening the user decided to use the private profile, but then happens to have to pay and wants to use the company credit card. It's on the different profile. So for such applications, having them in the profile, the user experience is not that nice. And because of that, well, basically it was even operators found out, yeah, it's not that nice. Operators that use that. And they said, yeah, we need something else. And now the something else, it's called SAM, Secure Applications on Mobile. It's a separate GSMA project. And well, it's, let me see. Now I think the requirement specification is out, but there are still discussions ongoing on how to implement it. And really there the idea is all those third-party applications, let's put them into a separate security domain, or well, let's call it a separate area. And at least that's called the SAM ST. And that's basically the always on area. Now, in the past, maybe you've heard of common security domain. That was a different name that we had in the past for that. And now that SAM-SD is always on, and at least if you then have one profile that's enabled, you could basically merge the applications and that security domain with the applications and that you have in the profile. And so it looks like it's just part of the profile, and if you then go to profile 2, it would be part of profile 2. If you switch to profile 3, it would be part of profile 3. Now, that looks easy, but it could have some challenges. if you basically integrate it with the profiles. And that's, well, on a typical, well, Java card, global platform card, AIDs have to be unique. Now, in the worst case, it could happen that, I don't know, because he didn't pay attention or whatever, an MNO loads a profile which has a, let's say, MasterCard applet on, and there's also a MasterCard applet in the SAM SD. And then you have a conflict of the AIDs. And now in worst case, it could happen that the SAM SD is already on and then the profile gets loaded. Now the question is, then do we want to reject now the loading of that profile? Or which at least then would keep it clean, but I think operators would not be very happy if that happens. Now then you could discuss, well, do you want to give some priority, but and then if the profile is enabled and has the payment application, do you want to give priority to the profile? But the impact for the end user may not be that nice. If the end user really wants to use the one in the SAM SD, then suddenly that becomes unavailable. So we have, for that one, we have to deal with AID conflicts. Now there's something else which, yeah, is a little bit harder to explain. There's something which is called the secure element access control, which basically today on a SIM card, there's a list of which applications in the phone can get access to which of the applications on the SIM card. The same works for embedded secure elements. That's secure element access control. The problem is that those lists, they also have some, well, allow all or forbid all except for a few others. They have those default settings. Now, the problem is that you can have such access control lists in the profile, and you can have access control lists then for the SAM SD. And they suddenly could also be in conflict with each other, because if there's a forbid all in the profile and the SAM SD has an allow all, okay, then which one wins? Because at least for the outside world, if it's really integrated into one hierarchy of security domains where you have the applications located, and then the outside world does not have any idea of that, and so on. That's why the simple integration on one chip and handling it on one interface, which looks the same, is a little bit complicated. And next slide, what at least is currently is being discussed and what we may see in the future is something where even the SAM domain uses a separate logical interface. And in some way, I would call that that's now the next generation of eSIM. If you look at multiple enabled profiles plus SAM, is that each of those basically gets its own logical interface. The profiles are nicely separated from each other, and the SAM domain is also separated from the profiles. And by putting also the SAM domain into a separate, what we call logical secure elements, that's the ETSI speak on it. By that one, well, many or most of those problems then are solved. So that's the use cases that we have and where we want to bring some solutions. And now with the next slide, let's look a little bit at the technical details of the solutions which are currently at work in standards. Now back to my introductory slide on MEP. Down here at the interface level, we're talking about multiplexing of logical SE interfaces, or LSIs. So that's the abbreviation that you will get confronted with if you work in ETSI. So that's the logical SE interfaces, and then we have also the logical SE. So basically what you see on top there, the operating system plus the profile, the virtualized one, that's then called a logical secure element. So we don't talk about virtualization, maybe also because of that being able to misunderstand it. ETSI language, it's logical secure element. And ETSI, now we need it in GSMA, but the work is done in ETSI. So some people said, yeah, that's really, I say, down on the platform level. That's why it shouldn't be done in GSMA. It should be done in ETSI. I was a little bit in favor of keeping it in GSMA so that we can basically even control the timelines of that. Some others were against. We'll see on whether ETSI will deliver in time for what we need in GSMA. We'll see. In ETSI, it's the technical committee SET. I don't know whether you've heard of that one. It's just rebranding. So it was the smart card platform, but because similar to what we did in GlobalPlatform, where we changed from the card committee to the SE committee, they now also changed from smart card platform to secure element technologies. So that's now same people, same group, same specifications, but new name, TCSET. And in fact, well, the idea was to do it in ETSI, but then there was some communication with ISO, and we have the ISO working group 4. In short, typically it's ISO IEC JTC1 SC17 working group 4. So these are this is the group that has the 7816. And in some way, it's technology which is also relevant for any kind of secure element. That's why working group 4 is now also working on it. Now we have to see on how good the cooperation will be. Hopefully there should be one standard that fits all, but in case we cannot agree and so on, then there may be even flavors of it, which would not be that nice. Work is ongoing. Let's see what the outcome will be. All right, now for what we, for what we do in ETSI. Okay, I explained we have logical SEs and logical SE interfaces, and currently what we define there, and it's still in progress, but that's the best preview I can give you, is we'll define a new APDU, which is named Manage LSI. And that's really one APDU that does everything. And the most simple thing is that you do simply a select LSI. And basically when you then send one APDU which says select LSI number 4, and then all subsequent APDUs will simply go to LSI number or to the LSE sitting on LSI number 4 until you switch again with the next select LSI. So very simple on that one. Now what we found out, what we need in addition is if you have a secure element today, you can simply reset it. But now if you have 3 logical secure elements, you may only want to reset one of them and not all of them. For example, if you now change a profile on baseband number 2, then you only want to do a reset on baseband number 2, but not affect the communication which is ongoing on baseband 1. So that's why we now have sort of that reset on the logical level by simply a different variant of the manage LSI command for reset LSE. Then we are discussing whether we need to close an LSI. It's basically if you have your dual SIM phone and the end user decides, well, you have a dual, well, I should say a dual baseband phone. And on a dual baseband phone, you can have now an EUACC that's multiple enabled profile that can handle multiple enabled profiles. So you can have 2 profiles of that. But at least in the beginning, we expect that there will still be a physical SIM slot. And now the end user could decide, nah, I need my physical SIM. And in that case, it may be useful to simply tell the EUACC that, by the way, this logical interface now is closed because the end user is using it for the physical SIM. And then the secure element knows, okay, for the time being, only one profile and the second one is basically shut off. that's for close. And then we'll have most likely one setting of the command which we need for this negotiation at the beginning of a card session, because at least, well, if it's static soldered, it may not be necessary, but it may be helpful to, for example, exchange information even there about which LSI is closed and which is open at the beginning of the startup, or if it's on a removable, then how many of the logical interfaces are even supported and so on. So this is what we are working on. Now, the nice thing about standards is that there are so many variants to pick off. And that's why even on that one, we are seeing some movement on, well, further variants. And that one variant now is related to the select LSI. And with the proposal that you see here, really everything that's related to logical SE interfaces is handled via an APDU now, but some people come up and say, yeah, but maybe we want to do it different. And at least for the selection of the interface that's being used. Now, the interesting thing is that even if the selection is doing with a different mechanism, you still have the reset and the close mechanism and the startup negotiation, which will use an APDU. So in some way, it's, yeah, call it a split logic, however you want to have it. Now, before I show you those alternatives, I would like to say one thing. We have multiple logical SEs, and in some way they run in parallel, but it's not really parallel processing and complete time sharing, multitasking, and so on, because the granularity of, well, data that we send to the CQ element for processing is still on APDU level. And you can basically see that if you have the manage LSI with select LSI, that's one APDU, which will tell, okay, the next ones are for logical secure element number 5. And then you see one APDU for logical secure element number 5. Then you have another manage LSI for secure element number 4. And then you have the APDU for number 4. So it's basically really one APDU at any point in time. Now, that's at least one paradigm that we will keep also with the alternatives proposal, even if there you could now start thinking about even doing it different, but that would really bring a level of complexification that currently nobody is thinking about. Okay, now to the alternatives. On the interface, we have some, well, basically we in real life, there are two options, t = 0, which, well, works everywhere, and t = 1, which at least in the mobile environment is not used. I can even say not used at all. But t = 1 has an interesting feature, and that's an NAD byte, node address, NAD, node address byte. No, the D is missing. Sorry, forgot what it is. And that's basically something that's currently unused, but that can be used for setting up different logical connections. Now, the NAD byte, as shown here, it's 1 byte, has a structure. For historical reasons, there are 2 bits which were related to, I think, something like the voltage supply for programming voltage and so on. Those are no longer used, are set to 0, which means that you have 3 bytes left for something which is called the destination address, and 3 bytes for the source address. And really the idea was that it's like a little network, and you can have several entities on the network, each one having 1 address. Now you could use that for multiple enabled profiles, and for example say, okay, the terminal has address 0, and then you can have address 1 to 7 for the different secure elements. So that's one option on how the NID byte could be used to indicate the LSI. Then you could basically directly send block frames to a logical secure element. Now what you can see here is the information field. It's only up to 254 bytes, and at least if you have a full-size APDU, then you need to change several of those. Now, technically, it would be possible to then send part of an APDU for logical interface 4, the next part for logical interface 5, and so on, and sort of to even, how should I say, split APDUs and interleave them. But at least in the standard that we'll have, that's forbidden. So only one APDU at one time, and only once the response data is fully sent back to the terminal, then the next APDU can come. Okay, now it has some limits. It's 7 logical secure elements only, unless we now start messing up with the address system that's in the ISO specification, where at least some discussions are also ongoing. In my understanding, that would conflict with ISO, but other people have different understanding. And well, when we talked with our ISO experts, Werner being one of them, basically there's some understanding in ISO that the NAD byte is really intended for being used on a physical network, that you don't have only a point-to-point, but sort of a network connection with multiple destinations, and that's not really intended for logical secure elements. Maybe a little bit of philosophy, at least that's one option of using that mechanism being discussed in ISO. Next one, in GlobalPlatform, we built on the T=1, created something that's T=1 prime, which is used for SPI and I2C, which really has some advantages because the payload is down here is the block format. You have a length byte of 2. The remaining part is more or less the same. But for example, if that's the mechanism to be used on for T=1, T=1 prime could basically adopt the same mechanism, and even if you have APDUs transported on SPI, that would work. Now, the interesting thing on that protocol is that they added also some S blocks for resetting. So for resetting, yeah, basically this the secure element, which you could then use to reset a logical secure element. So with that approach, you would even have a mechanism on that logical link level being used for reset, and you don't need an APDU. So really, it's interesting how many variants you could come along with. Now we have I2C, and currently I3C is promoted for it's really the serial communication that you have between chips on, for example, inside a mobile phone. It can be sensors, power regulators, MCUs, whatever, and it could also be a secure element. And in that specification, they already talk about virtual targets. A target typically is one chip, but then one chip could emulate several, one chip is called a target. It could have several targets on board, where he would basically mimic several of those, and that would be called virtual targets. Could also be used for the logical SEs. So that's something where ST basically mentioned that, yeah, we have some nice mechanism there. All right, so that's what's going on in standards, all still being in process. And we'll see what comes out. We hope that we'll finalize the specifications. Well, for GSMA, it's mid of next year, and we hope that ETSI will also be there at that point in time. Now, okay, after all that part, now what's really the impact for Java Card? And that's now, well, has some interesting things. Now, here's the Java Card, more or less a picture which is taken from the ETSI Java Card API specification TS102241. which on the left side you see Java Card, runtime environment, and packages and so on. And then you see a little bit the extension that ETSI defined for the cut runtime environment with a toolkit registry, toolkit handlers, and so on. And so that's what you have today on one SIM card or for one profile. And we have a nice change request, and I have to thank IDEMIA for that because they provided that drawing. It's in one change request where simply you say, okay, take your complete Java Card environment, and at least logically, it completely applies to one secure, one logical secure element. So if you have profile 1, it really sees the complete environment separate from profile 2 and from profile 4 and even the SAM security domain. And now I only put here Java Card in the headline, but the same basically applies for global platform. Typically on a global platform card, you have an ISD, issuer security domain, and which on a normal card is unique. Even for the profiles, we did some little bit of exceptions. But then here you would now have an ISD in the secure element 1, another ISD in logical secure element 2, and so on. And you can have additional security domains. They can have the same AID. Really, things are nicely fenced off so that everything really looks like the environment that we know today for Java Card, for global platform on one secure element. So that's a nice and simple view. And not everything is completely as simple as that. And these are then my last slides on that impact. Back to multiple enabled profiles. What we discussed there now, well, with the previous slide, what you could think of, let me skip back. You could think of a static environment where you basically have one SIM card, which is always there, and then the replacement of an embedded secure element, which is always there, and nothing changes over the lifetime. Then you can nicely have that separation. Now in real life with the profiles, we have a little bit of management, and basically we want to provide a mechanism to the user to switch the different profiles, which means compared to a SIM card today, we have some management layer or an addition for management. And at least from the modeling, from the architecture, we put that into a security domain, which we call ISDR, like the root ISD. And this is basically the entity that management commands are sent to. Now, at least one approach is that we say, yeah, let's put all that management stuff onto a separate logical interface, because then it's nicely separated from profiles and it doesn't mess around with profile communication. So if we send an enable command to enable profile number 3 on logical interface number 2, where currently we have the profile number 2, then that will go to the management. Now the problem is that after that management, at least in some variant that we are discussing in GSMA, then there's a need to send a reset command on the logical interface number 2. But that would sort of be triggered from logical interface number 1. And that's why now suddenly in ETSI we are discussing, two proactive commands, toolkit commands, where we could signal from one logical interface that, yeah, by the way, there's some cut activity, proactive activity on another logical interface, which you could say in some way extends a little bit that a nice separation that we have. And that's really what we do in ETSI. We have that proactive command, LSI command, which based on some management actions will trigger something which, goes across the boundary. The first one is that there's a proactive session ongoing on a different logical secure element. So please check for something ongoing there. And the other thing what we can do is to also trigger a UACC platform reset. which may, for example, kick in if you take that again and if you do an OS update. And after an OS update, now really depends on how that is done, but at least one option would be that now the secure element would use a proactive mechanism and tell the device, the phone, yeah, now we really need a restart, which is used, the command that's used is a refresh. And for a full reset of that of that platform, which would basically be the normal ISO reset. But that would then also be a command which is then triggered on some management port, but would affect all the rest. So these are two things where we really cross a little bit the boundary. Now that has some impact on the Java Card API that we define in ETSI, because stuff like that really should never be triggered from any applet that's inside a profile. So that will be restricted to be a system command. And the interesting thing is that it's not a system command on on today's operating system level, but really on that management level. Now that's one thing where there's a little bit of an impact. And now we may have in the future a little bit more impact, and that's also now related to SIM cards. On SIM cards or on profiles, we have something like proactive polling, basically a status command every 30 seconds. Now, if you have two profiles that are enabled there, then it basically means you send one APDU to profile 1, another APDU to profile 2 every 30 seconds. And only basically to check, is there something to do? Now, getting back to that one, you could basically also think about, well, why don't we send that request directly on the management channel, and then any profile that needs to have needs to do something can signal that one, and it basically reduces traffic a little bit. Maybe an option in the future, and then something like LSE management service that would come, and that would then also have some impact, at least on the ETSI defined Java Card environment. So that basically concludes my presentation, and I think now it's time for questions. I didn't see anything in the chat, did I? Okay.
Thank you very much, Karl Eglof, for this interesting presentation. The transmission was perfect, so no problem.
Mobile phones work.
So the question, are there any questions from the audience? Currently, I see one question. What entity do you assume to be an owner of an eSIM to manage MNO profiles, for example, installation of profiles? Who will be the owner of the ISD -R? And what entity do you assume to be an owner of a SAM-SD to manage SAM-SD applications, for example, installation of a SAM-SD application?
Yep. Well, ownership, yes. Basically, at least with the wording that GlobalPlatform picked and called it the issuer security domain for the ISD, it was always, okay, that's there must be some issuer and he's responsible. And yes, in some way that was really some lengthy discussions in GSMA, who is now the owner. And in some way, now don't ask me for the legal stuff and so on, but if you take mobile phones, the owner is the end user. And there in GSMA, we really make sure that it's, well, for the consumer, I'm only talking for the consumer, not for the M2M currently, that for the consumer, it's the end user that has the control. And that's why basically the end user will trigger any activities that are related to the ISDR. And the end user will then basically also trigger, for example, the download of a profile by, well, giving the address with a QR code and so on. And in some way, what we have in GSMA, it's a PKI system. And there's no real owner, but all certified servers that we have, we call them SMDP, so the servers for profile download. All those servers, as soon as they are certified by GSMA and have their PKI certificate, they can basically then download to that ISD. That's why I would say the ISDR, it's the end user. And I know that this is a difficult problem in M2M. It may be the M2M service provider there. But how should this, in some way, and that was a little bit more also political, we have several ISDs even in the eSIM specification. We have the ISDP, which is a profile that was really more a marketing idea to be able to sell it to get it approved. But yes, you still have kind of an ISD inside the profile, which behaves like more or less the container on that one. Now in the SAM security domain, currently the idea is that it's also based on a PKI mechanism like that, and that certified authorities can download. So the classical ISD that we know, based on symmetric keys, you always have one counterpart on the other side. As soon as you go to a PKI and you base the secure channel to the ISDR in that case, or maybe the SAM SD on a PKI, suddenly the ownership discussion is gone, because it's all certified entities can then basically talk via a secure channel to that ISD. And yeah, I think we have to get rid a little bit of that ownership idea with the ISD as soon as we go to a PKI system. And in SAM, I think they are still discussing on how they would set up their PKI and who would play that CI role. It may still be interesting, and there were also some discussions about, well, will there be several? For example, will there be one PKI which will be controlled a little bit by the OEM that sells the phone? Will there be one which is then again controlled by GSMA like we have it for the eSIM? Those discussions are still open, and there's no clear specification yet. Okay, I think that should have answered that question, right?
You mentioned, I think there are requirements for several virtual secure elements or logical interfaces. How many virtual secure elements do you expect in, let's say, from the GSMA side?
Yeah, well, that's also a very interesting question, because if you look at multiple enabled profiles, I think there it's the answer is easy, because as many as basebands you have in the phone, there for each baseband you need a logical interface, which means currently I'm only aware of dual SIM phones, but not triple SIM phones, plus one for the management. Now for the SAM domain, well, the picture that I've shown you was that for this, yeah, here we have it, that for the SAM domain, it's really just one interface. Now, it seems like in SAM, they are even discussing of some fragmentation a little bit further, so that each application that you have in a SAM domain gets its own logical interface. Or in some way, you could say that it's like each application. So if you have a MasterCard application, it more or less has its own logical secure element. And if you have a Visa in parallel, they are not sitting in the same logical secure element, but they basically get their own logical secure elements. Which means that if you look at, for example, secure element access control that comes with it, and so on, that would then also get separated. Now, if the SAM domain, if the SAM project really decides now to go with an approach where each application that you have then has a separate logical secure elements, and then suddenly we could have quite many of those logical secure elements on one of those chips, which then would also incorporate SAM. And that's why, for example, I think if that's a direction that will be taken, then the multiplexing, which I showed on T=1, where you only have 7 logical secure elements, it could already be too restrictive. On other solutions and so on, the limit is much higher.
Okay, thank you. You mentioned also that there is a need for adaptation of other standards from GSMA, ETSI, GlobalPlatform, Java Card. When do you think, what is the time frame for these adoption of the standards? When do you think, when should this be finished?
In some way, you could say yesterday.
Okay.
Now, for example, if you take the multiple enabled profiles, and if you took a note of the iPhone, the latest iPhone 13 that came to the market, I think Apple calls it a dual eSIM, but they basically already have a pre-standard of multiple enabled profiles out. And that was basically because in GSMA, well, we wanted to finish the version 3, which has the MEP already long ago, but there were delays, and at least, well, one manufacturer decided, well, then let's not wait, but put that out. So multiple enabled profiles with that kind of virtualization is already out in the field. And well, other OEMs basically want to do the same, and that's why there's some high pressure to get that finalized. In GSMA, we want to finalize that standard, which has multiple enabled profiles by mid of next year. Well, then if you look at the implementation, but then the standardized implementation, we could probably see then 2023 on the market. For SAM, I think they're a little bit later. We have to see, because well, they're still in some of the architecture discussions and so on. But dependent if they also finish by the end of next year, and then I think it shouldn't be it might also already hit the market in 2023. That's roughly the timeline now. ETSI, we still hope that, well, what we need in GSMA from ETSI, that this will be available at the same time frame. Well, currently from GlobalPlatform and Java Card, the assumption is that we don't need any changes there, because basically what I showed you as changes, that's really only on the currently on the ETSI part. Now, maybe there will be some statements in those specifications too, which basically make it a little bit more generic also on their level for having logical secure elements, but that's not really needed for what's going on in GSMA, and where currently the mobile industry really has some high interest on getting those things to the market.
Okay, thank you. Are there any other questions from the audience, also by microphone? I think the microphones are unmuted. If not, oh, sorry. If not, I would like to thank Karl Eglof again for this interesting presentation. And as I already mentioned in the beginning, all registered participants will receive the link to the webinar presentation, recording, and the material by email shortly after the presentation. Be aware that there is another interesting presentation as a part of the Java Card Forum 2021 webinar in this week, tomorrow, Thursday the 16th. Please don't forget to register. Finally, I wish you a pleasant day or evening, and hope to hear you and see you again soon. Bye-bye.
Bye-bye.